Since we just got done learning about segments and all of their relationships, what we're going to get into now is angles. This video is going to be pretty short because we're only going to focus on vocabulary. Instead of doing examples as well, we'll do examples in class, but if you're learning asynchronously, you can find examples in videos under extra resources. So before we talk about any relationships within angles, we actually need to talk about what an angle is. So an angle is defined as the union of two rays with a common endpoint. Okay, a union of two rays with a common endpoint. So if I was going to draw that as a diagram, and you've seen angles before in your life, I'm sure. So that's a ray. That right there is another ray, and you can see they share this common endpoint right here. So let's go ahead and quickly label. I need 3 points to name an angle. So if I have A, B, C, I can say that this is angle ABC, or I can say this is angle CBA. You have to have A in the middle of those 3 letters because B is the vertex. It is the shared endpoint of those 2 rays. So that's what an angle is. Now let's talk about the 4 different types of angles. So I'm going to go ahead and draw them, and then we'll talk about what they are. This first type of angle is called an acute angle. And an acute angle is an angle that has angle measures less than 90 degrees, but greater than 0 degrees. Less than 90 degrees, but greater than 0 degrees. The next type of angle is a right angle. And a right angle is an angle that is exactly equal to 90 degrees. And there's actually a special symbol that we use in an angle to represent that it is a right angle, and it's that square right there. Now, you can never assume that it's a right angle unless you see that symbol. So do not assume without this symbol. So either you'll be told this is a right angle or a 90-degree angle, or you'll be given the symbol. And so that symbol also represents a 90-degree angle. Just because it looks like it's a 90-degree angle, if that symbol is not there, you cannot assume that it is a 90-degree angle. It could just as easily be an 89-degree angle or a 91-degree angle, where it looks very similar, but it's not quite. So you need either the symbol, or you need to specifically be told that it's a right angle or a 90-degree angle. The next kind is called an obtuse angle. And an obtuse angle this time is going to be greater than 90 degrees but less than 180 degrees. And then finally we have this last angle A, which is a straight line, and it's called a straight angle, which, as you can see, is made up of 2 opposite rays, and a straight angle is equal to exactly 180 degrees. So those are the 4 types of angles that you're going to see. I really want to specifically pay attention to the straight angle. A straight angle is a line because it is made up of 2 opposite rays, and we learned in 1.1 about opposite rays and how they create lines. But what you need to know is that every line is 180 degrees. Okay, every line is 180 degrees. All right, let's talk about our last bits of vocabulary. We have 2 more vocabulary words, but before we do those 2, let's talk about something called the angle addition postulate. And the angle addition postulate states, if point P is in the interior of angle RST, so notice that we're being given an example in order to explain the postulate. If it is in the interior of angle RST, then the measure, and I use a lowercase m to show the measure of angle RST, equals the measure of angle RSP plus excuse me, I forgot my measure symbol. The measure of angle RSP plus the measure of angle PST. And this is going to make a lot more sense once we draw a diagram, okay? So let's go ahead and draw a diagram. So here is my angle, and I can draw whatever kind of angle I want. Let me draw mine like this. So right now it's just a random angle. If I want to follow this postulate, the first thing I'm going to do is I'm going to put P in the interior of angle RST. Okay, so first let's call my angle RST. So here's R, here's S, here's T, and I'm going to put P in the interior. So interior means inside, so there's P. Then the measure of angle RST, so the measure of this angle right here, the whole angle, is equal to the measure of angle RSP. Okay, well, I have to create angle RSP. So I start at R, I go to S, and I have to go up to P. So my angle is just like this right here. Okay, there is now a ray going from S to P. So the measure of angle RSP, this angle right here, measure of angle RSP, plus the measure of angle PST, measure of angle PST, is equal to the measure of angle RST, is equal to the whole angle, that whole angle right there. Okay, so hopefully drawing out the diagram makes a little bit more sense. And it's the same thing like segment addition postulate. This is angle addition postulate. The sum of two adjacent angles creates that whole angle right there. And finally, our last two vocabulary words are congruent angles and angle bisector. Now think back about the word congruent to segments that were congruent. Congruent segments were segments that had the same length. So congruent angles are angles that have the same measure. So angles with equal measure. So say I have two angles, angle 1 and angle 2. Why not? If angle 1 is congruent to angle 2, that means that the measure of angle 1 is equal to the measure of angle 2. And think back to segments. How do I represent a length of a segment versus how do I represent the name of the segment? Same thing here. How do I represent the measure of the angle versus how do I represent the name of the angle? And the last one is an angle bisector. An angle bisector is a ray that divides, a ray that's in the interior of an angle that divides the angle into two congruent, remember congruent is this symbol right here, angles, into two congruent angles. So if I have this angle right here, let's again call it RST. And again, let's do point P on the interior with a ray. If, say, ray SP is an angle bisector, then this angle here is congruent to this angle here, okay? So ray SP would be called my angle bisector, which makes angle RSP and angle PST congruent. Like I said, we'll do examples in class Or if you're learning asynchronously, you can use the extra resources posted in the assignment.